Today I'd like to give you a comprehensive introduction to CHOPS. CHOPS in Houdini stands for Channel Operators, and a channel is just a time series. That is a sequence of numbers where the numbers change over time. And to motivate the idea for channels and CHOPS and why they're useful and interesting, I would like to do a basic animation with a sphere. So I'm going to first create a geometry node, and I will call it Geo. We'll go inside and create a sphere, which I will just call Ball. Now, there are several ways you can move objects around inside Houdini. You can keyframe them, you can use simulations, and we'll see in a moment that you can use CHOPS. But we are going to use keyframes to motivate the idea of channels and CHOPS. So first, I'm going to Alt-left click on the center to set a keyframe. Come forward a little bit. We'll take the ball and move it in one direction and another, and set another keyframe. Go forward a little bit further in time, move the ball over here, maybe change the Z coordinate again, Alt-left click, go forward again, move the ball way over there, Alt-left click, and then we're going to return to the beginning at the origin where everything X, Y, and Z are all 0, Alt-left click. Now if we play this back, the sphere will move from one keyframe to the other and back to where it began. So what is interesting about working with keyframes is if we select the ball and come over to the animation editor, you can see how the X, Y, and Z parameters change over time. So the X, Y, and Z coordinates are channels, to use Houdini's term. The name of those channels are TX, TY, and TZ. And the names you can find if you come over here to the center and just mouse over it and wait, you'll get a little pop-up describing this parameter. And the center parameter, the values are named TX, TY, TZ, T for translate. And the animation editor gives you a nice visualization of those three channels, of how they change over time. So these three sequences of numbers, these channels, control the motion of the ball. These three channels are attached to the geometry, however. If we had other shapes, for example, we could copy and paste this path to that or reference it using expressions. But when you think about it, the path is one series of data. Well, it's actually three channels of data. And then you have the shape. There's no reason they have to be connected. And that's the big idea with channels and CHOPS, is channels and CHOPS allow you to create sequences of numbers independent of geometry. They don't have to be connected to any shape whatsoever. And then you can use an export node or an export CHOP, as we'll see, to connect those numbers to specific parameters on specific shapes. And let's give that demonstration now. So we're going to take our ball node, we're going to come down here and delete all the keyframes that we just made. So I'm going to right click on the center parameter, come down and delete channels. That's why they're called channels, because they don't say delete parameter or delete values. They're calling them delete channels because that's what the X, Y, and Z coordinates are. They are data channels. So right click, delete channels. Now let's create a CHOP network. You can create a CHOP network at any level throughout Houdini, and I'm just going to call it Choppy. And we're going to go in now and we're going to create a path. That means we're going to create a series of numbers for X, Y, and Z that is not connected to any geometry whatsoever. And to really make this interesting, I think it would be better if we had more than one shape. So we have a ball right now. Let's add a box, and I will call that just box. And then let's make a torus, and I will call that donut. And let's select these three shapes, come down and merge them. And we now have three independent shapes, although they are on top of each other. So let's just move the ball to the left, -2, and the donut to the right, 3. How about? There we go. So we have three different shapes, and what we're now going to do is use channels to create a path that's not connected to any of these shapes. And then I will show you how you can take that path and how you can assign it to any of these three shapes, or you can even assign it to all of them. So let's go into the chop network called Choppy and let's make a channel. There's a lot of different ways you can do this. I'm going to focus on how you can do it using Python, Vex, or using some of the built-in chops that will do the math and calculations for you. If you do tab and come down, there is a create folder of chops, and there's several different chops here, several different channel operators for creating channels. I'm just going to select channel, and let's call this path. We saw that when we moved the sphere around in space using keyframes, we were able to see its path or see its channels using the animation editor. For chops, however, you're going to use the Motion FX view. Now we need to kind of dive in and say, how do we actually make 3 different channels of data using chops? When you select this and you come down, you'll see there are 3 tabs here. There's Common, Channel, and Data. First, let's create the channels. The channel range is set to full animation range, which is good. And the sample rate is important to look at. That is, how many numbers per second do you want to have? When you're working with video, 24 frames per second, you'll want to have 24 numbers per second. If you're working with audio, which you can also do with chops, you'd be working with something like 48 kilohertz or 48,000 numbers per second. But we're working with paths, which is a video thing, so we just need 24 frames per second. The data. Now, what is the name of this channel? Let's call it position. Now, when you're making channels, it'll ask you how many channels do you want to make. So this is interesting. Let me do Control B and go full screen here. There's 2 different ways we can make X, Y, and Z channels. One is, let's say, make 3 channels. We could call this, say, X, this Y, and this Z. That's one way to do it. And you could come down here and say, use a Python expression. So you could have something like sine of time, the cosine of time, or just 0.2 times time. So that would be one way to create 3 channels called X, Y, and Z and give them values using Python. We can see them if we come over to the Motion FX view. Let's click on the home button so that we can see everything. One thing I've noticed with chops is the default colors tend to be quite dim, at least for me. If you select the chop, come down to the Common tab, you can change the graph color. If you pick a bright yellow, it will then use bright yellow as kind of like the starting color, and then use slight changes in colors for all the different graphs that you'll see. So here you can see we have an X graph, a Y graph, and a Z graph. So we have X, Y, and Z channels. If you come over to your chop and click on I and look at the information for this, this is a very important window to become comfortable with. First, it lets you know there are 3 channels, X, Y, Z. What is the sample rate? It's 24 samples per second. There are 10 seconds in the animation by default, so that gives rise to 240 samples. And that's the chop term. Samples is what they call numbers. So you have channels, which is your sequences or time series, and samples are the individual numbers in those channels. Now keep in mind, this 240 numbers is per channel. There's 3 channels, so 3 times 240 is 720. When we're over here, if you press the D on your keyboard, that D for dots, it'll display dots for every single sample that occurs. So this is one way you could create an X, Y, and Z channel. Now let's see how to use it, and then we'll come back and create X, Y, and Z in a maybe a more interesting and user-friendly way. So we've created a path, and we'd like to use it. So how do we do that? There is a chop called export. And this is what you say, what you want to do with these numbers. So what are the channels we have? If you click the drop down, it'll let you know what channels are available coming in. There's X, Y, and Z. So let's say we want to export X, Y, and Z, and we want to use them as the X, Y, and Z coordinates of one of these 3 shapes. Remember, the coordinates are called TX, TY, and TZ. So now we have to decide which of these shapes we'd like to animate. If we click here, let's go and select, how about the box to begin? So we have the box and we do that. Now we're going to hit play, but prepare to be disappointed. Nothing happens. And why is that? That's because to export the channels, you have to come over here to this little flag on the outside, the export flag. If that's not on, it's not actually going to take those numbers and apply them to anything. So when we click this, you saw the box jump, that's a good sign, and we hit play, there we go. Not a very fast circular motion, but the data is now being taken from this chop and copied over to the X, Y, and Z coordinates of the box. Is there a way that you can visually tell, other than just playing back, to make sure that this is working the way we want to? There is. If we go up, we have the ball, box, and donut. Notice on the box node, we have the little stopwatch, the green stopwatch. That's an indication that there are parameters here that are changing. So if you select this node, look at the center, which were TX, TY, TZ channel names. And the background color is this light bluish green color. And there's this little stripe on the right here. That color on the parameter box matches the color of the export flag. So that's to let you know that the data for the X, Y, and Z values is coming from a chop. And in fact, you can toggle back and forth between the values of the X, Y, and Z, and oftentimes you'll see expressions here, but in this case, if you just mouse over and wait, you'll see that it's overridden by the object geo choppy export 1 X. Meaning if you come to choppy, there's the export 1 node, and it's the X channel. That's what's overriding that parameter. If we were to change this to copy to geo, come back up, select box, mouse over, and wait, you'll see the path updates. So if that's the chop node, that's the channel node that it's getting the data from, and it's getting the data from the X channel. Now, if we come back into the choppy network here, we could say, let's, instead of the box, let's do the ball. Now we play this back, and now the path that we defined is being mapped over to the ball. Now, what if we did something goofy, like object/geo/star? It's now applying this to some of them. If we come up here, and you'll now see there's little stopwatch icons on all three shapes. If you select one, come up here and mouse over, you'll see what value or what channel is being used here. Note, look here, it's X, X, X. This is Y, 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 and so forth. It's a little weird, I'll admit. I always find this a little bit confusing at times because there's this kind of looping behavior, which we won't really focus on because that starts to get into some fancy things. But I would, in general, you could select either an explicit geometry that you want to do, or let's see, what if we do something like this? Okay. So yeah, if you want to take these X, Y, and Z, this path that we made, and assign it to all three, instead of using an asterisk, you could just add them one at a time. So we could come over here and say add it to the ball, accept. Add it to the box, accept. Oh, it's overwriting, sorry. So we have the box, the ball, and the donut. Now when we play this back or scrub through, it's using it all. So that is one of the drawbacks of using the asterisk, is you have to really understand this, how it does all the, it's just a little bit of a mess. But that shows that there is a lot of interesting flexibility here. And in fact, I would argue that maybe, this is a bit of a tangent, I apologize, but if you want to take and export this path to three shapes, you could do something like this. Have more than one export node. And we could call this to box. We could call this one to ball, and we could call this one to donut. Now we could go through this one. It's going to the box node. This one we could say go to the ball node, and to donut we could go to donut. Also, let's make sure we fix the fact that we want to take all of the channels, X, Y, and Z, and map them to TX, TY, TZ. Same with donut. Although, We could go a little crazy here, and they don't have to be in that order. You pick the order you want to put them in. So if you want, you could say you'd like X to go to TZ, Y to go to TY, and Z go to TX. That's entirely up to you. So don't forget the export flag. So let's select all of them, click on export, because without the export flag, it won't actually copy them over. And now we play them back. The ball seems to be missing, and that's because the ball is inside the box right now. To confirm that, if we go up here, we're going to take the box and we're just going to reduce the size a little bit so that you can see the ball. Now there we go. So you can see the ball and box are moving along the same path, but the donut, we kind of mixed things up a bit. We took X, Y, and Z and mapped it to Z, Y, X. So this is one way to create channels and to use channels. Now I would like to show you a slightly different way of doing this using some of the built-in chops or channel operators. So let me stop this, and I'm going to delete this path. Okay, now hit Tab, come down to Create. We use the channel node to kind of start this. Actually, I'm going to rewind a bit. There was another thing I wanted to show you. Create the channel node. We came down here and said we wanted 3 channels. And then we went through and used Python expressions to define them. There's another way you could do this. Let's call this POS for position. There's this size box. Let's increase this up to 3. Now, although it says the number of channels is 1, if you come up to the chop and click the eye, you'll see there are 3 channels. And they're named POSX, POSY, and POSZ. That's because using them to apply to X, Y, and Z parameters is such a common use that you can just give the base name here, set the size that you'd like it to be. It can be anything from 1, 2, 3, 4. If there's size of 1, the channel name is just POS. If the size is 2, you'll have POSX and POSY. And if you have 4, you'll have POSX, Y, Z, and W. But we're interested in just position, so we will have 3. And then here we could define the Python expressions like we did previously. I'm just going to do slightly different expressions to make it a little more interesting here. There we go. This kind of naming convention that it has, where if you have only one channel, it's more like a channel set, and you just give the base name, it will go through and append X, Y, and Z to the name that you put here. I actually found this a little bit confusing the first time. It didn't feel like modern Houdini. It felt kind of old. And there's a reason for that. Channels are very old. Chops in Houdini predate version 4, before the year 2000. I mean, it's a very old feature of that. And I think this kind of illustrates its age. It just doesn't have that nice polished feel that some of the more current nodes and features have. But not to digress. By the way, we can just double check that everything's working by coming over to the motion effects view, turning on the visibility flag, and we can see, yep, we now have POS X, Y, and Z, and now it's all ready to use. So we could once again use the export channel. If we wanted to, we could say apply all of these 3 nodes to TX, TY, TZ. By the way, if you want, you don't have to type POSX, POSY, POSZ. You could just use an asterisk and it'll work for all 3 nodes. Let's apply this to the ball, turn on the export flag, never forget that, and now we play it back. There we go. I think it'll be a little more interesting this way. There we go. And once again, if you come up, you can see there's a stopwatch on ball. If you click it, you can see it's overridden by POSX, POSY, and POSZ. So that is 2 different ways you can create 3 channels using Python inside a chop network, and to take those 3 channels and apply them to a geometry by specifying what you want to apply them to. Now, let me go ahead and come in here and delete this and reset our view. There we go. If you hit Tab, come down to Create, you'll see there's a few other things in here, like Wave, for example. If you select Wave, and let's come over to Motion VFX and Display, and zoom in here. This will give you a sine wave without your having to type in the expression for a sine wave. And you can come over here and grab these little handles for adjusting the amplitude, the period, the phase. You can also come over here and even add a decay if you'd like, so that it's kind of like a dampened spring or something like that. So you can do this mathematically if you know the mathematical expressions to produce this curve. But if you don't, and you'd rather have just a nice handle to do something like this for you, you can come over here, create this shape using this wave chop. There's other ones as well, like for example, there's noise. Let's turn this on and hide the wave. And so this gives you a lot of different parameters to go through and create a noisy channel of data that you can then use. And chops also has other things for like combine. You can do things like there's a math node that will allow you to take a oscillatory wave plus some noise and combine them together. This is intended to give you a point and click way to build up a curve without having to type in the mathematical expressions. It works, it's very limiting. I would actually encourage people to become more familiar with like how do you use sine and cosine to get the things. And there's also lots of Python and Vex functions for doing noise and all this other stuff. So anything you can do using these other chops, you can do by an expression in a more compact way. So let's return to our wave and let's hide the noise. And we have this dampened oscillation, and let's just increase the amplitude. There we go. So we have a nice little dampened oscillation. We can now apply this to one of our shapes. So we could say, let's export this to one of the parameters on one of the shapes. We can say we have a channel 1. It's called Chan 1 because if you select this wave node, come over to the channel tab, this is the name of the channel. Once again, this interface just feels a little old that I think nowadays if this was made that it would be on this primary panel. So this I will just call wiggle, or how about dampened? And the range is full animation range, that's good. And so we're going to come to export. Notice here it still has Chan 1. It didn't rename. Another just feels a little out of date to me. Select dampened. We're going to go over to the donut and we're going to apply this to how about the Y position. Once again, don't forget to turn on the export flag, come out a little bit and play. And there you go. The Z value is oscillating, but it's dampened oscillation, so you can see it's slowing down. And if you want to, you could apply it to TX and TY, and you'll get this little diagonal oscillation back and forth. So it's a flexible thing. You could say take this one value and copy it to on the donut TX and on the donut TY. Or you could also do something like, we could apply it to all three, TX, TY, and TZ. There we go. So this is one thing you could do. You can become more familiar with all the different ways to create shapes, like a constant number, some noise, a pulse, which is more like jumping up and forward, up and down. So if you select the pulse chop, look at it, come over to the Motion VFX view, you can see it's more like a metronome, like just a knock, knock, knock. And then you can go through and combine these things together using like the math chop and things like that. And that's another way. You can build up these channels of data, and then by using the export chop, you can say, use this data to control this geometry, that geometry, or all the different geometries. And finally, I'd like to show you how to create channels using Vex. And to do that, we're going to use the channel wrangle chop. Let me first call this Vex path. We come down here and they want to know what channel names do you want and how many channels do you want to make. So if you're doing a path expression, I mean, you'll want to have three numbers here, X, Y, and Z. So how do you do that? Like before, if let's say you gave your channel name P and say you want to make 3 channels. If you look at the information of this, you'll see it did make 3 channels and it named them P0, P1, P2. So the earlier trick of it adding X, Y, and Z to it no longer applies. It now numbers them. Also, look at the number of samples it made. It didn't make 240 numbers for us. It only made one. And the reason for that is if you come over to the channel tab, look at the channel range. At least in my case, it defaults to use current frame. A little bit frustrating. You want to use full animation range. You don't want to create a number for just this one frame. You want to make a whole time series of numbers starting from frame 1 and ending at frame 240. Now we come back and look at the information. There's now 10 seconds worth of data, 240 samples, 240 frames. Okay. I personally, this is a personal thing, instead of creating one name and having it append numbers to it, I just like to come up with the names myself. So let's call them alpha, beta, gamma. Look at the information pop up. We now have 3 channels named alpha, beta, gamma. Each channel has a sample rate of 24. There's a total of 240 samples because 24 samples per second, 10 seconds. Now, let's define what these numbers should be. And the trick here is you have to specify how to iterate over this. Like right now, there's a lot of iteration options. And you have channels and samples. So we have 3 channels and 240 samples. So it's like we have a 3 by 240 table in a spreadsheet. We want to fill those with numbers. And do you want to go like horizontally and then vertically, vertically then horizontally? You want to do them all in one big chunk? In our case, we want to go from top to bottom, and we're going to go every 3rd channel. So that means we're going to do 3 channels at a time. So what do we want to call those channels? We get to specify the names we want to use in our vex expressions with the iterate names. Let's call them x, y, z. Let's say x will be sine of 2 times t, y will be cosine of 2 times t, and z will be 0.3 times time. Now if we turn on the display flag, come back to the motion VFX view, there we go. Once again, the color is dark. I like to come to common and select a nice bright yellow. I just think that would be a nicer default than the dark blue. And you can see the names of the channels are alpha, beta, and gamma. So like before, now that we've created the data using a vex expression, we can just export them. Turn on the display flag. Actually, we don't need to worry about that. Make sure we turn on the export flag. That's important. What channels? We have alpha, beta, gamma. What node do we want to put this on? This time let's use the box. What parameters do we want to map these to? We could say alpha, we'd like it to go to tx, beta could be tz, and gamma could be ty. Play that back, and there we go. We have circular motion with the linear motion going up. If we stop this and change the order here and play it back again, we now have circular motion moving slowly down the z-axis. So there you go. 3 different ways to make channel data. We used Python expressions using the channel chop. We played around not too much using things like the wave and noise chop, and we saw how you could use those to like wire together data without having to type any expressions. Or you can use the channel wrangle chop and create channel data using vex. Once you have the channel data you want, you can then use multiple export nodes. We did that once, but the export node will allow you to say copy these channels to these parameters on that node. And if you want to copy the same path to different nodes, you can have multiple export chops, or you can get a little bit fancier with how you type in the channels, nodes, and path. So I hope you found this helpful, and I will see you in the future.